Hi, the purpose of this video is to teach a science lesson to a class. It is for ITL 518 at National University. So for my video, I will be teaching a lesson to a second grade class focusing on the Next Generation Science Standards 2-PS1-1, Matter and its Interactions. Plan and conduct an investigation to describe and classify different kinds of materials by their observable properties. Hi friends, so we get to do a fun, exciting science experiment today. We get to make slime. So we're making slime because we want to understand what a polymer is and how chemical reactions can change the state of certain ingredients. Any ideas how we can do it? What ingredients do you think we're gonna need? We're gonna go over our ingredients and our materials. So first, I'm gonna put on my handy dandy apron so that way I keep my clothes clean. And then we're gonna go through the other materials we need, okay? All right, materials. We need washable PVA glue. We're gonna use clear, but you could use white also. Then we're gonna need baking soda, saline solution. It's what you use for your eyes when you wear contacts. Food coloring, I chose turquoise. And to spice it up, we're gonna add glitter because I love glitter. We're going to need measuring cups, half a cup for the glue, half a cup for our water, 1 teaspoon for the baking soda, 1 tablespoon for the saline solution, and then we just kind of get to guess how much of each we'd like to put. I'm gonna say a squirt and a dash. And then we need a spoon to mix, and then I'm gonna wear gloves so I can keep my hands clean. Let's get started, I'm so excited. Step 1, mix half a cup of glue and to the half a cup of water. Step 2 is we're gonna add the food coloring and the glitter. I'm gonna do 2 drops of the food dye. 1, 2. Close that up, and then I'm gonna do a dash of silver glitter, dash, and then a dash of the light blue glitter, dash, okay? Next, we're gonna mix in our baking soda. So we need 1 teaspoon of baking soda. Level it off, pour it in. Then our next ingredient is going to be the saline solution, which is also known as contact solution. So the saline solution has the boric acid in it, and that is what's gonna connect the glue and make it into a solid. Now we're gonna stir it up. Stir it up, stir it up, stir it up. And you can see it starting to get sticky. Once I stir it, I'm gonna get in there with my hands, which is why I'm wearing gloves. And then I'm gonna knead it until it makes the shape and form that we want. So what is slime? Slime involves chemistry, and it's all about the different states of matter, including liquids and solids and gases. It's all about the way we put the materials together and how they are made up of atoms and molecules. Additionally, chemistry is how these materials act under different conditions. So when they're separate, they're one thing, but when we mix them together, they make another thing. So what makes slime stretchy? Slime is all about polymers, like we said in the beginning of the lesson, right? So polymers are made up of a large chain of molecules. The glue that we used in the slime is made up of a large chain of polyvinyl acetate molecules, which is why we need to find glue that says PVA washable glue. These chains slide past one another fairly easily, which keeps the glue flowing. The chemical bonds are formed when you mix the glue and the slime activator, which was our saline solution, and then they change position of the molecules in the glue, and that process is called cross-linking. So a chemical reaction occurs between the glue and the borate ions, and the slime is the new substance that is formed. Instead of flowing freely as they did before, the molecules in the slime have become tangled together, and then they create what we call slime. They begin to tangle until the substance is less liquidy, and then it starts to get rubbery and thick, right? When we play with it, so slime is a polymer. But is it a liquid or is it a solid? Trick question, it is a non-Newtonian fluid, so that means it's a little bit of both. We can squish it to make it a solid, and then we can stretch it, and then it becomes kind of liquidy. That's super cool, right? All right, so here is how our slime turned out. It's definitely still a liquid type form. It's sticky, but we want to add more of a polymer or more of the borate ions to the mixture to make it solid. That's right, we want to add more of the borate ions. So we're going to squish some in there and keep kneading until it becomes the consistency that we want. After adding more of the borate ions to make it more of a solid consistency, we've got our slime. Super fun and cool, right, you guys? So cross-linking changes the viscosity or the flow of the new substance. And that's how we got slime to be so stretchy. Thanks for following along in my lesson today. I hope you enjoyed it as much as I did.